Hello everyone, what's going on? I'm Garry from Master974 back again today, and welcome to another Valve source code tutorial follow-up video. And today I'm going to be following up on the Physgun tutorial that I did quite a long time ago at this point, and I'm just going to be going over some fixes for some serious issues that I would have left when I did that original video. So for example, the issues I'm going to be covering include fizz surfing, where if you stand on top of a physics object and use the Physgun, you'll get launched up into the air until you'll eventually fall and die. There was a game crash where if you had a chain of welded props but one of them was breakable and you broke said breakable prop, then when you tried to grab one of the other props in the chain, then it would actually end up crashing the game. And there's also an issue about reloading gravity pellets out of the void. So I like how I said in that video towards the end that an expert in this sort of coding stuff would be needed in order to fix these issues. I guess I'm a coding expert now, according to myself from 5 years ago, although I would not consider myself a coding expert by any means. So to give a bit of a brief high-level overview of the causes of these issues, fizz surfing happens because the code doesn't perform any checks to see if the player is standing on an object that can be grabbed, and the effect update function only returns if the distance between the object and the player is 36 units, but the typical distance for fizz surfing is more in the 65 to 75 unit territory. The game crash related to welded props is because of the pellet list struct. It doesn't actually update or remove array elements when gravity pellets are destroyed. It would require the gravity pellet code to access the struct that's defined in the Physgun code, and it's not easy. And because the struct doesn't actually remove any elements, it tries to access null elements, causing invalid reads and then reading garbage data and crashing the game, so that's not good. And the ammo reloading out of the void occurs because the game just simply gives the player the maximum amount of ammo when the reload button is pressed. So we're going to be fixing that in this video. And there's also an issue where the beam disappears if the player grabs an object and then looks behind it. So we'll actually be getting to that fix first. So it's actually on the client in CUweapon-gravitygun.cpp. It's also worth mentioning I've already done minor follow-ups to the Physgun in the past, including view model bobbing and creating D-lights along the beam for the Physgun. So I'm not going to be talking about that here, I'll just point you to the videos where I talked about these fixes. But to make it so the beam actually draws when you're looking away from an object when it's being held, you just want to go to the getRenderOrigin function and change m_world position to m_target position. And that's pretty much it. If you compile the code at this point, then you should see that if you, for example, weld a barrel to a wall or support column or something and then grab it, it won't move, but if you turn around and look up, look behind the barrel, then it'll cause the beam to draw. Now, I think there are still some issues where, especially if you have an object that's up against a wall of some description, that it will end up causing the beam to disappear. So there are some issues with the beam still, but it's mostly improved. Now there's actually one other minor client follow-up that I'm going to do here, which is regarding the renderable to world transform function, because I've actually looked into how that function works in other client files. So I'm going to be giving a sort of basic implementation of that function in CUweapon-gravitygun.cpp now. So you want to remove the stock matrix 3x4_t and the return lines, as I'll probably show in the video here, and then you want to make the const matrix 3x4_t called and renderable to world transform function look like this instead. So you want to create a static matrix 3x4_t called mat, then do set identity matrix of mat, then position matrix of getRenderOrigin mat, and then return mat. Okay, so what I'm going to do now is cover some server-side changes, and the first thing I'm going to do related to the ammo situation is to add a ConVar to HL2GameRules.cpp called skMaxGravity, and so you define it as I show in the video. You can put inside the speech marks skMaxGravity, then in a second set of speech marks 0, And then for the flag, FCVAR replicated, like all of the other ConVars in this file use. And then in the def.addAmmo type section, you want to modify the gravity ammo type by changing the number 8 or whatever value is there to represent the max ammo with, inside the speech marks, SK max gravity. Now if you want to, you can actually add an ammo pickup for the Physgun using the glue blob models. So if you want to do this, you want to go to itemammo.cpp and you want to add the following. So you want to add an hashtag define called size ammo Physgun pellet and give it a value of 1 glue blob equals 1 pellet, and then create a class called CItem_Physgun pellet public CItem, and then declare that class by using, declare class of CItem Physgun pellet with a base class of CItem. Then you want to add void precache passing through void inputs, and in this function you want to do precache model of, and then in speech marks models weapons glue blob.mdl. Then in a separate function you want to have void spawn passing through void inputs, and in this function you want to add precache set model of, and then in speech marks models weapons glue blob.mdl, and then do base class : spawn. And the last function you want to add is bool my touch, passing through an input of a C-base player called *p player. And inside this function you want to say if item_give ammo of p player size ammo Physgun pellet, and then in speech marks gravity. Then in that if statement you want to have another if statement that says if g_p game rules arrow item should respawn of this is exactly equal to gr item respawn no, then util remove this. Then outside of that if statement return true, and then outside of the if item give ammo if statement return false, as you'll see in the video. And then outside of the class definition you want to do link entity to class of, then whatever you want to call the pickup, item ammo Physgun pellet in my case, and then the class that you called it, CItem Physgun pellet. Now I'm going to be going to Physgun.cpp, which is the actual server-side weapon code for the Physgun, but I will say up front that some of the code that I'm going to be showcasing might be leftovers from some testing that I was doing in the past, so it might not be strictly necessary, but I will go through the code that will resolve the issues that I outlined earlier sequentially, so let's just get into it starting from the top and working our way down. So the first thing I'm going to do is define a ConVar, and I'm going to call it something like Physgun pellets in play. You can call it whatever you want to, but I'm going to define it as inside the speech marks Physgun pellets in play, then in a second set of speech marks 0, so there's no pellets in play by default. You can give it a flag of FCVAR hidden, that way people can't find it in the developer console by searching for it. And if you want to add a help string, you can do. I just say that it's an internal variable to keep track of active Physgun pellets. Then you can remove the max pellets macro if you want to, we won't be using it. And now we need to make some changes to the CGravity pellet class. So first off, you want to add a constructor, in other words add CGravity pellet with brackets after it. And then at the end of the spawn function, you want to add obtain parent, which we're going to define right now. So after the spawn function, you want to add a C-base entity called *obtain parent, passing through void inputs. And in this function, you want to say pellet parent equals get parent, and then return pellet parent, as you'll see in the video. And then you want to go to the input on break function, and you want to add util remove of other pellet to remove. We'll be defining that in a second. And also event_killed of ctake damage info of this 0 damage direct. And then after the bool m_is inert line, you want to add an int called pellet index, a C-base entity called *pellet parent, and a CGravity pellet called *other pellet to remove. Now you want to cut the make constraint function out of the class definition and paste it somewhere in the gravity pellet code, and also change it so it reads bool CGravity pellet : make constraint, passing through an input of a C-base entity called *p object. But you also want to add a declaration for that function inside of the class definition for the gravity pellet. So in other words, you want to add bool make constraint, passing through an input of a C-base entity called *p object in the CGravity pellet class. Then after the data desk, you want to add a CUtlVector, which is inside of less than and greater than signs, C gravity pellet asterisk, and you can call it whatever you want. I'm going to call it active Physgun pellets. Now, I've been waiting for this video in particular to talk about CUtlVectors. So to give you a bit of an explanation of what a CUtlVector is, it is a source way of creating a dynamic sized array. It's an extension of the C++ vector class, which does the same sort of thing. And you can add elements to it, remove elements, create for loops based off of the number of elements that exist within the dynamic sized array, and find elements within said array. So I'm going to be going over all of that in this video. And so, yeah, it's just a dynamic array in the source engine. So in this case, we're creating a dynamic sized array of pointers to gravity pellets, which for all intents and purposes is just a list of gravity pellets that exist. And we're going to be using that to our advantage here. Not only to access it in the gravity pellet code, but also in the Physgun code. So that's quite nice. So you want to add the constructor now, C gravity pellet : C gravity pellet. Make sure you have the rounded brackets after it, and inside of curly brackets to define what the function is actually going to do, we're going to want to do this. So you want to have active Physgun pellets dot add to tail of this, add this specific gravity pellet to the end of the list, and then do pellet index equals active Physgun pellets dot count -1, then do a ConVar asterisk called ppellet count, which equals cvar arrow find var of, and then in speech marks Physgun pellets in play. Then an int called m_pellet count, which equals ppellet count arrow get int. Then m_pellet count plus equals 1, and then ppellet count arrow set value of m_pellet count. Next, you want to go to the destructor, which is C gravity pellet : C gravity pellet, which already exists. And after the if m_p constraint statement, you pretty much want to add the same thing that we added in the constructor, but you want to remove the pellet index line and change the m_pellet count line so that it says -=1 instead of a +=1. And you also want to change the active Physgun pellets line to dot find and remove of this instead of add to tail of this. So you'll see that in the video, as I just said. The next thing you want to do is go to the make constraint function, and below the m_p constraint arrow set game data line, but above the make inert line, you want to add this. You want to create a C-base entity called *p_test, which equals a dynamic cast of C-base entity of p_object, as you'll see in the video. And then if p_test, then for int I equals 0, I less than active Physgun pellets.count, and I++, you want to create a C gravity pellet called *p_pellet, which equals active Physgun pellets.element of I, and then if p_pellet arrow pellet parent is exactly equal to p_test, then other pellet to remove equals p_pellet, else continue. So what we're doing is iterating over all of the Physgun pellets, and if the pellet's parent is the test entity that we're considering, then we want to basically define the other pellet that's going to get removed if that object breaks. That's pretty much what we're doing here. And you can add a check to see if the pellet is invalid if you want to. And outside of the if p_test if statement, you can add an else condition to make sure that the test is, invalid. Not that that should ever happen. But you can add these error checks if you want to, just to make sure that the code doesn't end up entering any sort of invalid situations. Okay, so I'm going to be moving on to the actual Physgun code now. So the first thing that you want to do is go to the equip function and basically remove the powner arrow set ammo count line, because we don't want to be giving the player any gravity pellets when the Physgun is obtained. And also in the drop function, you want to remove the C-base player *powner and powner arrow set ammo count lines for pretty much the same reason. Then you want to delete the delete active pellets function declaration, and after the C-base entity called *getBeam entity line, you want to cut and paste the pellet list _t called m_active pellets and the int m_pellet count lines, which are actually in the private variables section. You can also replace the max pellets, because we might have removed that earlier, to any sort of arbitrary number that you want to. For example, I changed it so that it's an array of size 50, The next thing I'm going to do is go to the effect update function, and you want to add tr2 after tr, as you'll see in the video, to define a second trace underscore t. And then after the vector end line, we're going to add a vector called below player, which equals powner arrow get abs origin, and then do below player.z minus equals some arbitrary amount like 128 units. We're going to be using that in a CUtlTrace, so after the CUtlTrace line, you want to do a CUtlTrace starting from the start vector, ending at below player, which is 128 units below the player, and then for the bounding box, do minus vector of 32, 32, 0, vector 32, 32, 0, so that defines a 64 unit square that's going to be centered on the player, and then trace down 128 units to see if there's any entities below the player. And then do mask shot, powner, collision group none, and tr2. Then you want to go to the if m_h object is exactly equal to null and tr.didHit non-world entity statement. And below the apply multi-damage line, you want to change the attach object line so it says something like this instead. So you want to say if powner arrow get ground entity is exactly equal to p_entity, or tr2.m_pent is exactly equal to p_entity, then detach object, else, and then the attach object line, which should pass through inputs of a p_entity, start, tr.endpos, and distance. And then outside of this if statement, you want to add if tr.didHit non-world entity, then if powner arrow get ground entity is exactly equal to tr.m_pent, or tr2.m_pent is exactly equal to tr.m_pent, then detach object. Now this next fix I'm going to get to, I think was recommended to me either through DMs or on comments on YouTube. But basically what the issue is if you have an object that can be grabbed by the Physgun and can be picked up by the player, then you might end up getting a crash that happens inside of the sound update function because of a pointer called pphys getting set to null, and that should not happen. So to fix this, inside of the sound update function, after the iPhysics object called *pphys line, you actually want to change the fade line so you have something like this instead. So you want to create a float called fade, which equals 100, and then if pphys, you have fade equals util line fraction of pphys arrow get mass 50 500 1.0, as you'll see in the video hopefully. Then you want to go to the add pellet function, and you want to remove the assert line because we've modified the ammo situation for the Physgun now. And after the m_pellet count ++ line, you want to add ppellet arrow set parent of pattach, and then ppellet arrow pellet parent equals pattach. Then you want to go to the sort pellets for object function and change the contents of the for loop, so not the for loop itself but the actual contents within that for loop. So you have a C gravity pellet called *ppellet, which equals active Physgun pellets.element of I, and you can also add an error check to see if ppellet is null if you want to. And then you want to change the contents of the if statement so you actually have, instead of what's already there, if ppellet arrow pellet parent is exactly equal to p object and !ppellet arrow is inert, but then leave the rest of the function unchanged. Then you can delete the delete active pellets function and go to the attach object function, and after the m_distance equals distance line, you want to add if m_distance is lower than 36, then return. Then you want to go to the primary attack function, and at the very start of the function add m_fl next primary attack equals gp globals arrow cur time plus 0.1. And then in the secondary attack function, after the vector endpoint line, as I'll show in the video, you want to create a vector called distance, which equals powner arrow weapon shoot position minus endpoint. Then create a float called magnitude, which equals distance.length. And if magnitude is greater than 512, then return. Now you also want to make sure that you have the weapon sound and powner arrow remove ammo lines after the if magnitude is greater than 512 check. But in this case what will happen is we won't create any gravity pellets if the distance between the player and the endpoint is greater than 512 units. That distance is completely arbitrary, by the way, you can change that to whatever you want. Next, you want to go to the weapon idle function and you want to remove the if has weapon idle time elapsed if statement and the curly brackets that relates to that if statement. And after the m_active pellets line, you want to add ppellet arrow obtain parent. And then in the item post frame function, after the cbase player *p_owner checks, you want to add a ConVar asterisk called ppellet count, which equals cvar arrow find var of, inside the speech marks Physgun pellets in play. Then create an int called total pellets in play, which equals ppellet count arrow get int. Then m_pellet count equals total pellets in play. Okay, now I'm getting to the last thing I'm going to change for the Physgun code in this video, which is about how to make the Physgun reload pellets in a singular fashion, and how to make it so that the pellet has to be in range in order for it to be considered to be reloaded in the first place. So you can pretty much remove everything after the cbase player *p_owner line inside of the reload function, and keep the last return false line. But then after the cbase player *p_owner line, you want to add a cbase entity called *pent, which equals getBeamEntity, and then create a for loop starting from int j equals active Physgun pellets.count, j greater than 0 and j minus minus. So one of the first times you'll ever see me actually create a for loop and starting from the high end rather than the low end. But then inside of this for loop, you want to create a cgravity pellet called *ppellet, which equals active Physgun pellets.element of j minus 1. And then m_active pellets of element j dot pellet equals ppellet. Then create a vector called distance, which equals p_owner arrow weapon shoot position minus ppellet arrow get abs origin. And then create a float called magnitude, which equals distance.length. And if magnitude is greater than 512, then continue, which basically means if the distance between the player and the pellet is greater than 512 units, then skip that pellet and move on to the next one in the list. Then you want to create a vector called forward and do angle vectors of ppellet arrow get abs angles and then ampersand forward. And then do g_p effects arrow dust of ppellet arrow get abs origin forward 32 30. Then create a cbeam called *pbeam, which equals cbeam : beam create of Physgun beam sprite 1.5. Then do pbeam arrow point ent init of ppellet arrow get abs origin pent. Then pbeam arrow set end attachment of 1. Pbeam arrow set brightness of 255. Pbeam arrow set color of 255 0 0. Pbeam arrow relink beam and pbeam arrow live for time 0.1. Then do ppellet arrow event killed of take damage info of this 0 damage direct. And then p_owner arrow give ammo of 1, then m_I secondary ammo type. Then m_pellet count minus minus, weapon sound of reload, return true, and then the return false line can be outside of the for loop. So everyone, that is all of the code changes that I have for you today. If you save and compile the code, then you should see that fizz surfing should no longer work. You won't get game crashes if you have a weldable chain of objects but one of them breaks. You should have the ability to reload pellets singularly, and there's a distance consideration. You shouldn't be able to reload them out of nowhere, and also the beam draws correctly when you're looking away from an object. And also any objects that are grabbable by the player, that would also not crash the game now. However, this is far from ideal because there are some issues that still exist. For example, there was one instance where I was able to do fizz surfing, although I think it's actually way more difficult to do it now than it was previously. Not quite sure what the circumstances are for that to happen, but it can still happen, so just be mindful of that. And also, I've noticed an issue where you might just suddenly see a held object rotate to a sort of default orientation, then the game will crash, and it will crash somewhere in vphysics.dll, and since that code is inaccessible, it's pretty much impossible to trace the cause. And even in this video, I actually had a completely unique crash that I've never seen before, that crashed somewhere in the engine code, and I don't know why that happened. It was supposed to be this v-physics crash, but yeah, there's still some issues with the Physgun and the functionality. I personally think it has something to do with the grav controller code, but I wouldn't know. Now I know what a lot of people are probably going to say in the comments. Have I figured out a way to get the Garry's mod style rotation of objects working? Obviously, because I haven't covered it in this video, the answer is no, I haven't actually figured out a way to get that to work. A viewer did reach out to me providing some form of an instruction manual about how to add that feature, but it didn't actually end up working, so that's still up in the air, and if you have any ideas about how to add that, then it'll be greatly appreciated. And the last thing I'm going to get to with this video, because I've been going for over half an hour now in this audio recording if you can believe it, is that it would be nice to get rid of that pellet list struct that I was on about earlier, because the only variables that are contained within it are a normal vector, a parent object, and a gravity pellet. Now through my experimentation I was able to actually remove most instances where this struct was used, but there was one instance, one function that I just couldn't resolve, couldn't get working with the CUtlVector method that I implemented in this video, which was the sort pellets for object function. I couldn't get that to work, and I don't know of a good way that you could go about actually getting that function to work with the CUtlVector method that I've showed in this video. So if anyone has any ideas about how that function in particular can be changed or reworked to accommodate for the CUtlVector, then it would be greatly appreciated. And with that, the pellet list could get completely removed and would no longer be needed. But everyone, that is the video. I hope you found it helpful. Please let me know what you think. Hopefully you'll check out the next follow-up video, whatever it might be. And as always, like, comment, share, subscribe, and have a great day.